Hey guys, we're still looking at the guided notes for solving by square roots. And really at this point you have the basics for what you need to be able to do. But now I'm looking at the rest of these notes and it's just kind of figuring out the structure and how to deal with the different types you could be presented with. For example, on this one, it looks a little overwhelming because I do see the quadratic term. I see a constant, which is similar to the ones we just did. But I also see some extra x's hanging out. Now, a quick reminder for your algebra, if you have a quadratic term and something that's not quadratic, they are not like terms. You cannot, should not, and would be incorrect if you did, add those like terms because they're not like terms. So, instead, we need to find the ones that are like terms, and the only things that are alike are the two linear terms here. So I'm going to try and get them together, and since they're on different sides of the equal sign, I can't just combine like terms. I'm going to use the subtraction property of equality. So since I see plus 2x here, I'm going to do the opposite, which is to subtract 2x from both sides of our equal sign. Which means we would be left with an x squared on the left side of the equal sign. We'd have a 200 on the right side of the equal sign, and that'd be it. So we've pretty quickly simplified this already and gotten rid of everything except for our quadratic term and our constant. So I don't want a quadratic. I don't care what x squared is. I want to know what x is. So the opposite of squaring a number is to square root a number. So we're going to solve by taking the square root of both sides of our equal sign. I'm going to go ahead and remind myself that that generates two solutions, a positive one and a negative one. And 200 is not a perfect square, and even if you weren't sure, we're going to figure out what it would be by breaking apart 200. I happen to know that's 2 times 100. There's lots of other ways to get 200, but I'm going to use that, which gets me my first prime number, and then I'm going to keep breaking this down. There are lots of different prime factorizations you could use, but in the end we should all end up with the same 5 numbers. So I see 3 of those 2, so inside the radical I will have a 2 times a 2 times a 2, and I see 2 5s, so 5 times 5. Pairs make perfect squares, so 2 times 2 is 4, the square root of 4 is 2, which means outside the radical is a 2. Pairs make perfect squares, 5 times 5 is 25, the square root of 25 is 5. And left alone inside the radical is that 2 that didn't have anyone to pair up with. So when we put things back together, we're finding that the variable x is equal to both positive or negative 10 square root 2. That's our simplified solution. Let's do another one. Looking at E, 4x squared equals 49. This one doesn't look too complicated. However, it gets a little weird if we're not careful, and let me just show you. So there's no plussing or minusing, which is nice. You don't have to undo that. When 4 is directly in front of the variable, it means multiplication, so I'm going to divide. Now it's really tempting to just say, well, I don't know what 49 divided by 4 is. I'm going to throw it in my calculator and I'm going to get 12.25, which is not wrong, but it's really not helpful. I don't want a decimal for this, so I'm not going to get a decimal. This is already a reduced fraction. There's nothing that divides into 49 that also divides into 4 other than the number 1. So I'm just going to leave it like this. And as weird and unnatural as that looks, it's actually not too bad because I'm going to solve by square roots. I'm going to knock out this squared by square rooting. And I'm going to do it to both sides of the equal sign. When you solve by square roots, you generate two solutions, a positive and a negative one. And specifically, I have the square root of a fraction here. So you can think of that as the square root of the top of the fraction over the square root of the bottom of the fraction, which is pretty easy to simplify because those are two perfect squares. The square root of 49 is the number 7. The square root of 4 is the number 2, which means I'm done with this problem. I get plus or minus 7 halves, which, yes, the square root of 12.25 would have given me 3.5, unless I've done math wrong in my head. But why pick up a calculator when this work is already done? I guarantee I could do that quicker than you could find a calculator. So you don't have to. In fact, we don't want you to. We'd rather you leave this in the fractional form if you happen to get a problem with the fraction in it. Let's see if this one has a fraction in it. This one does have some subtraction to deal with. So again, ultimate goal, get x by itself. Goal right before that, let's get the x squared by itself. So let's move everything that's not x squared. I'm going to start by adding 16 to both sides of my equal sign. So we'll be left with 25x squared on the left. Remember, that's 25 times x squared. And 16 on the right. So since I don't want to be multiplying, I'm going to do the opposite of multiplication, which is to divide. I could maybe take a ballpark guess of what 16 divided by 25 is, so I'm just not going to bother. I do realize that none of the things that divide into 16 also divide into 25, because 25 is only divisible by 5 and 1 in itself. None of those things go into 16 other than the 1, which means this is a simplified fraction. So when I go to get rid of this squared term, when I solve by square roots, I'm going to take the square root of the numerator, square root of 16 is 4, and I'm going to put it over the square root of the denominator. The square root of 25 is 5. And because I solve by square roots, I will have two solutions, and I'm done. Plus or minus 4/5. Yeah, since this one doesn't turn out like this, I'll go ahead and stop this video so it doesn't get too long. This one will be slightly different, and we'll pick it up in a second.